So I know that we learned about domain restrictions earlier, but there are no domain restrictions here because we never use division.
Okay, so now we've come to how to do inverses. Inverses are not a new thing whatsoever. They're not a new operation. They're just simply taking your x's and y's or your inputs and outputs and switching them in solving. So the way that works is, like if I take a look at this notation again, this is not an exponent, right? This is simply the notation for inverse. It wants me to find the inverse of f. And what I do is I realize, for the sake of solving, that f is really y. So I write down y is equal to 12x minus 9, and I switch the variables x and y. And these can be done with any variables, but you're used to, at this point, seeing x's and y's. So the y becomes x, the x becomes y, and everything else drops down. That's what the operation denoted here means. So that, again, is the inverse. However, it's not written in a way that we're used to seeing. This is correct. This is f inverse, but it's written in terms of x. So I now need to solve it for y, just like you did in Algebra 1 or geometry. You're going to get rid of the constant and put it over here. We're solving for y just like you did when you solved and graphed linear equations. So here I have x plus 9. Here this will cancel. This will drop down. And then I will divide by 12, but I will remind you of something you've probably heard. When you divide by 12, you have to divide each thing by 12. It's not a great idea to draw a large line like that because it hides some simplification from you. So when you divide this by 12, you can divide this by 12 and this by 12. It just makes your simplification a little easier. So here we get 1/12 x minus 9/12, and 9/12 we reduce to 3/4. So that is the inverse, written in terms of y, but to denote it correctly, we have to use f inverse, just like it said to use up here. So y is f inverse of x, and then we would write our answer down. So keep in mind that that bar that a lot of people will write across, what it does is it hides the simplification, and in this case, you might recognize this as a linear equation. If I would have just drawn a big bar right here, it would have hidden the slope from me as well as this simplification. All right, let's take a look at the next example. So here we have inverse of g. So we would write down y instead of g, so you just write a y here, and that would equal 3x. The inverse operation is to simply take the x and the y and switch them. So we would have an x here and a y there. That is the operation, so then we would drop down everything that we didn't use, and we would solve for y. So the way we solve for y here, it's pretty simple. We just divide by 3. Now keep in mind that x over 3, again, we have a linear equation here, is 1/3 x, because we want to know what that slope is. So if we just say x over 3, sometimes that gets hidden. And the only thing that's wrong with this now, I mean, it's done, is that we're not using the correct notation of inverse of g. So I'm going to write g inverse, which is the question, right? And then I'm going to write down the answers. So a lot of my students will ask, why can't we just say y equals? We used to. Well, there's several reasons. Number one, there are no y's on the paper. We use the y as a placeholder for g. Otherwise, we'd have to write a lot more. The other reason is if I write y for each of these answers, it's hard to know which inverse is g's inverse if they're all labeled y. So we want to make sure that we get rid of this y and label it which problem it is. We want to make sure that we do that here. This is f's inverse, not y. This is g's inverse, not y. All right, let's take a look at our last one. Notice I modified it slightly. I got rid of the x that's in several of the other examples here because that solving technique will be learned later in the year. All right, so to do this problem, again, this is a y, so we would write down, remember, just as a placeholder, we would write down y equals x squared minus 5. We would switch the x and the y, so we would take this x and y, and we would switch them. And that's not going to change Remember, it's important to do the operation without doing anything else. That is the operation, switch x and y. Everything else drops down. So now you can see that even that square dropped down because I have not used it yet. Now I will solve this, and for those students who don't remember how to solve this from Algebra 1 or Geometry, it solves the same way these other ones do at first. So you would add 5 to both sides, okay, and you would combine like terms, and the difference is going to be in the next step. It's pretty easy, and you'll probably remember it. So you have x plus 5, and then you have y squared, and the way you get rid of a square is to take the square root. So we would simply take the square root here. So the square root of x plus 5 is equal to y. And some of you might know that this needs a plus or minus on it. Some of you might not know that. So if you're already ready to put a plus or minus here, go ahead and do it. It doesn't have to be on there at this point, but we'll go ahead and put that on there so that you're ready for it. Okay, so the y needs to be changed to h inverse. So I'm going to change it to h inverse and write it properly. So it will become plus or minus the square root of x plus 5. And the reason that that happens, if you're wondering why there's a plus or minus at this point, you might remember that this is a quadratic. So this is going to be graphed in this shape. Okay? The square root would only have half of this. So the plus, it would be the top part of the inverse. And then the minus would actually be the bottom part of the inverse. And that's for a later chapter, but that's why that plus or minus needs to be there, so that the inverse physically looks like the original function when it's graphed. But that's for another chapter. All right, I hope you enjoyed this video, and thank you for watching.